Water, water everywhere, water everywhere, and all the boards did shrink. Water, water everywhere, nor any drop to drink. From the rhyme, The Ancient Mariner by Samuel Taylor Coleridge. An Imagine that all the water on earth equals 100 gallons. 97 gallons would be ocean water. 2 gallons would be ice. 8/10 of a gallon would be groundwater, and that leaves only 2/10 of a gallon for all the rivers, lakes, wetlands, clouds, water vapor on Earth. Check it out. Water has 3 states: solid, liquid, and gas. Can you spot each phase in this photo of Earth? Picture sailors stranded on a ship in the middle of the ocean. There's waters everywhere as far as the eye can see. After all, the Earth's surface is almost 3/4 water. But this water is too salty to drink. With no rain in the forecast, the sailors soon run out of drinking water. Their bodies dry out, and the sailors slowly begin to die. And every tongue, through utter drought, was withered at the root. We could not speak, no more than if we had been choked with soot. All animals and plants need water to survive. The human body is more than 3/4 water. Life forms use water to transport nutrients around the body and carry off waste. Water also helps break down food and keep organisms cool, among other vital jobs. What happened to the sailors in the Coleridge poem? One survived, thanks to rain. To tell the story, my lips were wet, my throat was cold, my garments all were dank. Sure, I had drunken in my dreams, and still my body drank. In ancient Greek mythology, Poseidon was the god of the sea. His Roman name is Neptune. In Japan, there are myths of kappas, mischievous water spirits. Kappas have webbed feet and hands, a turtle shell, and a duck's bill. They carry water in their bowl-shaped heads. Even microscopic life needs water to survive. Many one-celled organisms thrive in wet areas such as ponds. They are basically floating bags of water. Some with tiny hairs or tails for swimming. Their cell walls hold their innards. The innards are light sensitive and contain digested food particles and genetic material. Watery world record. Biggest ocean. The biggest ocean isn't the Pacific. It's all the Earth's oceans combined. Pacific, Atlantic, Indian, Arctic, and Antarctic. They flow into each other as they swirl through the continents, around the continents, forming one huge body of water. About 3/4 of the Earth's surface is covered in ice or water. How do tall trees transport nutrient-rich water from their roots to their very tops? After all, the trip can be several-story rise against the force of gravity. Trees have very long, thin phloems, or tubes. Water rises in these tiny tubes through a process called capillary action. Set the stem of a carnation flower in colored water overnight to see capillary action in action. To make colored water, add a few drops of red or blue food coloring to a glass of water. The superpowers of water. A substance. Several times each day, your body takes in a chemical called hydrogen oxide. This chemical has the power to eat away solid rock over a period of time. In its frozen state, mighty hydrogen oxide can crack concrete and destroy the cells of plants and animals. Hydrogen oxide is the chemical name for water. The chemical symbol for water is also familiar that water now has a nickname, H2O. The H stands for an atom of hydrogen, which is positively charged, and the O stands for an atom of oxygen, which is negatively charged. Thus, the water consists of a bond between two components, a positively charged hydrogen atom and a negatively charged oxygen atom, HOH, no matter whether it is found as a liquid, solid, ice, or gas, water vapor. Water may seem ordinary, but it has some properties that no other substance has. Water is a super solvent. Water has the power to dissolve other substances like no other substance. You can test many properties of water right in your own kitchen. A watery world record. Human water walker. Can humans walk on water? Frenchman Remy Bricacan. In 1988, he ski walked across the Atlantic Ocean on water skis that were a little shorter than a compact car. The long skis had the effect of spreading Brica's weight over the surface of the water, keeping him from sinking. His watery stroll took 2 months. A rising dome. The components of water stick together, thereby forming drops. The ability of the two components to stick together, called cohesion, causes water to form a skin on its surface. The force holding this skin together is called surface tension. With a straw or eyedropper, put drops of water on a coin. Do you see a dome of water rising above the surface of the coin? Surface tension keeps the dome intact, up to a point. How many drops can you add before the dome collapses and the water spills? Soap breaking the tension. Soap breaks the surface tension of water. Soap attracts dirt and other particles, helping to make dishes and other items clean. Set a dish of water on a level counter. Carefully place a small paperclip on the water's skin. This will take some practice. Then try to float a paperclip on a dish of soapy water. Without a skin, the soapy water cannot hold the paperclip. Supersaturated. Water, our super solvent, dissolves salt. Up to a point. What is this point? How much salt can water dissolve? Add a teaspoon of salt to a glass of water and stir. How does the water change? Keep adding a teaspoon of salt and stirring until the salt no longer dissolves. The grains of salt will fall to the bottom of the glass. Allow the water to completely evaporate over several days. What is left in the glass? The wind creates waves on the ocean's surface. Below the surface, though, other forces are at work. Ocean currents are strong channels of water, flowing caused in part by the meeting of warm and cold water. Warm water rises and cold water sinks. In this satellite photo, the warm current of the Gulf Stream, red, flows up the eastern coast of the United States. Cold currents from the Arctic, blue, flow down to meet it. A whirlpool. In the ocean is a giant version of the water that swirls down a drain. It swirls tighter and tighter and faster toward a hole in the center. Whirlpools can draw whole ships to the bottom of the ocean and then spit them back up. Luckily for us, ocean waves near the shore are too chaotic, disorganized, for whirlpools to form. Worth saving. As people who live in desert areas or who experience droughts know, water is a precious commodity. Worth saving. Why am I always so thirsty? A flushing toilet can use as many as 5 gallons per flush. Newer, low-flush toilets use 3.5 gallons. But you may have to flush more often, which does not save any water and may make the situation worse. Some restaurants won't automatically give you a glass of water. Every glass of water brought to a table requires 2 or more glasses of water to wash and rinse the glass. Since 75% of water used in a house is used in the bathroom, if you remember not to let the water run while washing your face or brushing your teeth, you can save up to 10 to 20 gallons of water per day. Since at least 97% of the world's water is salty and undrinkable, and 2% is polluted, polar ice or otherwise inaccessible, this leaves only 1% for people to use. Rain, rain, go away. Come again another day. Rain comes and goes all over the earth, never disappearing. In fact, the water cycle on Earth is a closed system. Water is very, very rarely lost to outer space. This means that the same water falls as rain over and over again. So water that fell as rain when the dinosaurs existed could be falling on you today. Rain that just fell on you may have fallen on someone in Spain someday and vice versa. How is it possible that the same water keeps moving around in one big cycle? If we could follow a raindrop, we would see how this endless cycle works. Following the dripping raindrop. What happens to rain after it falls on you? Follow the journey of one raindrop. As you do, keep this rule in mind. Water always seeks the lowest point to which it can go. Number 1. A raindrop bounces off your head and falls to the ground. Number 2. The raindrop seeps through the surface soil to meet with the underground water, an aquifer. 3. The raindrop joins an underground river and flows downhill between the sloping layers of rock beneath the ground. Number 4. The raindrop comes above ground where a spring of water pops up out of the ground in a valley. The raindrop within a spring waters flows into a river. The river flows downhill into the ocean. The raindrop in the ocean turns into a gas called water vapor, a process called evaporation. The raindrop rises, joining other vaporized raindrops to form a cloud. 8. Wind blows the cloud with the vaporized raindrop and its companions to Spain. 9. The cloud cools and condenses, causing the vaporized raindrops to turn into liquid water, raindrops. Number 10. In Spain, a raindrop bounces on a person's head and falls to the ground. Where might the raindrop go next? Where might the raindrop be in a million years? Hey, dog nose. Earth, the water planet. The Earth is often called the water planet or blue planet. Hydrologists, people who study the Earth's water, generally classify water into two groups, surface water and groundwater. Surface water is water found in rivers, lakes, ponds, glaciers, and other oceans. There is more water stored below the ground than in the surface groundwater. Groundwater is water that soaks into the ground, or rivers that disappear beneath the Earth's surface, or any water that soaks into the ground and is trapped between layers of rock. This trapped water recharges, or keeps filled, these underground aquifers, ponds, lakes, or rivers below the ground. Water also exists in the air as water vapor. Rivers flow. Even in the driest deserts, however, the water is often buried deep under the ground. Oases are fertile areas in the desert. They go deep enough below the sand surface to reach the underground water. Trees and other life forms, including humans, can thrive in these low-lying islands of moisture. What causes rain from clouds? Picture a wet sponge. Now imagine squeezing the sponge. Water drips out. The wetter the sponge, or the harder you squeeze, the more water drips out. What squeezes a cloud? Answer: coldness. As clouds cool, they condense, squeezed state. As the air cools, water vapor squeezes tighter and tighter until the vaporized particles or gas come together and stick to each other, and particles of dust in the air, see illustration. That must be that illustration there. When this happens, the water vapor turns into liquid water, which is heavier than air and also falls as raindrops. In the 19th century, so-called rainmakers promised farmers they could make it rain for a big fee. Many of these traveling rainmakers were rip-off artists, but today farmers can truly make it rain sometimes. Airplanes drop small particles, crystals, of pale yellow solid called silver iodide into clouds. The supercooled vaporized water particles in the clouds stick to the silver iodide and fall as rain. However, to make rain, there must be supercooled clouds, not blue skies. Dripping silver iodide crystals from airplanes into clouds to make rain is called cloud seeding. Above, the father of cloud seeding, Vincent J. Schaefer. Schaefer is a shepherd in German. Performs cloud seeding experiment in 1948. Watery world record. A waterlogged nation. Bangladesh is a low-lying country on the Indian Ocean. Its coastal locale and low altitude make it a wet and often dangerous place to live. During May or June, heavy rains called monsoons flood the lowest areas, including cities. Typhoons, called hurricanes in the Western Hemisphere, create large ocean waves that wash over much of the coastal area. In 1970, a tsunami, a giant ocean wave, killed more than 200,000 people in Bangladesh and left millions homeless. Icelands. The continent of Antarctica is a land of ice. Almost the entire continent, which includes the South Pole, is blanketed with ice. The ice blanket is several miles deep in parts, covering all but the very tops of the highest mountain peaks. Near the coast, glaciers, slow-moving rivers of ice and snow, crawl down the mountains and flow into the ocean. Sometimes chunks of the glaciers, some as large as a city, split off, crash into the ocean, and float off to become icebergs. At the opposite region of the Earth, an ice-covered ocean surrounds the Arctic, or North Pole. The ice cracks, crashes, and swirls on top of ocean currents. The ice cover shrinks in summer and expands in winter, but it never disappears. North and south, the polar regions of the Earth are usually beautiful places, frozen with ice. Snowy snapshots. Every kind of crystal has its own regular structure of atoms. Snow crystals are hexagons, six-sided figures. The crystals combine in various ways to form snow. The type of snow formed depends on temperature density, how packed the atoms are, moisture, and other factors. The cracked ice below looks eerily like the ice sheets that cover the Arctic Ocean, yet it's not on planet Earth. The cracked ice covers Europa, a moon of Jupiter. Europa might have a liquid, watery ocean underneath its icy shell. Where there is liquid water, there might be life. It was formerly thought that the moon had no water. Recently, scientists discovered ice in the moon's deepest craters. Perhaps comets put it there. Comets' heads are chunks of ice, of which 80% is water, ice, and rock that sometimes slam into planets and moons. Some of the Earth's water may have arrived via comets, but this is simply a guess. A glacier on the move. Glaciers, French for ice, begin as piles of snow in the mountain valleys. As some snow evaporates or melts, freshly fallen snow replaces it. Snow weighs a lot. Layers of snow press down, forming a compact ice called firn. Gravity causes the firn to travel down the mountain at a rate of several feet per day. In places, deep cracks called crevasses form. As the land becomes flatter, the glacier slows down and buckles, creating bumpy ice falls. The tip of the glacier advances and at other times retreats, depending on the amount of snowfall and the temperature. Rime is frozen water vapor. This frozen water vapor, or fog, a type of cloud, freezes on tree branches and other solid objects. The wind blows the ice crystals horizontally, parallel to the horizon. The rime looks like white, jagged flag on each tree branch. Check it out. Why can't you freeze lettuce without turning it into a mushy mess? Each year in St. Paul, Minnesota, artists create giant castles. They use a building material that is common in winter, blocks of ice from Minnesota's frozen lakes and rivers. Since 1886, the ice castles of St. Paul have been world famous. The 1992 structure set a world record of 15 stories. That's approximately 150 feet. Watery world record. Tropical icebergs. Most icebergs melt while still in polar or subpolar regions as they encounter warmer and warmer winds and ocean temperatures. In 1894, an Antarctic iceberg set a latitude record. It broke off the continent of Antarctica and floated north. It was spotted closer to the equator than any other known icebergs. Its record-breaking latitude, about 26 degrees south, is parallel to that of Rio de Janeiro, Brazil. Rio is known for its beaches and year-round warm weather. Most raindrops Rainbows form when sunlight passes through water droplets that remain in the air after a rainstorm. This rainbow is extremely unusual. It formed as sunlight passed through the ice crystals of a cirrus cloud. Woo, pretty. Clean Water Challenge. All 6 billion human beings on Earth need clean water to drink. However, not every human being gets clean water. Chemicals, both natural and artificial, can pollute lakes, waters, rivers, and streams. Bacteria and other organisms can make the water supply deadly to drink. Heavy metals and other minerals can also make water unsafe to use. Keeping the world's water supply clean is one big challenge. In many countries, children collect the family's daily water supply from a community well. The groundwater from a well has filtered down through many layers of soil and rock. These layers help clean out some contaminants, but not all. In the mid-1990s, school children in Minnesota reported seeing frogs with extra legs or missing legs. Since then, people around the United States have reported frog deformities to scientists. After testing certain frog habitats, the scientists found pesticides, chemicals used to fight crop pests. The pesticides may be one of the causes of the frog's deformities. A watery world record. Deepest lake. Lake Baikal in Siberia, Russia, is the world's deepest lake. At its lowest point, it is 5,715 feet deep. That's more than a mile. It is also the largest freshwater basin in Eurasia. Settling and skimming. Water is often stored in a reservoir or holding area. Some pollutants are heavier than water, so they naturally settle to the bottom of other pollutants. Other pollutants are lighter than water, so they float to the top. These are skimmed off. Settling and skimming remove about half of the pollutants. Aerating. Wastewater has very little oxygen, especially special tanks aerate provide oxygen to the wastewater. This oxygen encourages the growth of helpful bacteria and microbes, which eat the waste material and remove approximately 90% of the 50% of pollutants remaining from the settling and skimming process. Number 3, disinfecting. Chemicals such as chlorine are used to kill some harmful organisms. Samples are taken to determine the presence of bacteria. Filtering and distilling. This is number 4. At this point in the waste treatment plant, the water may still contain metals, pesticides, and other pollutants. These pollutants are expensive to remove, so not all treatment plants can afford to do this. Filtering the water through charcoal gets rid of carbon-based pollutants, such as pesticides. To remove salts and other minerals, a few special treatment plants distill water, boil it into steam. The pollutants remain as the steam rises and condenses. The liquid water is then directed into another chamber. Coagulation. Number 5. Sometimes treatment plants add chemicals in order to remove other harmful chemicals. For example, the chemical alum causes chemicals and waste particles to clump together. These clumps settle to the bottom of the storage tank as a gooey liquid called sludge. Number 6. Removing or reusing sludge. Treatment plants usually bury or burn sludge so that the sludge cannot re-enter the water supply. Sometimes the nutrient-rich sludge is used as fertilizer for crops. The sludge is also dumped into the ocean, but this dumping is now being rethought as it causes fish and other ocean organisms to die. And we're right at 24. It's a good time to turn the page. Water survivors. All life on Earth depends on water, but what if there's not enough water in a place, such as in a desert? Or what if the water is super salty, super hot, or super oily? Extreme water conditions call for extreme methods of survival. Some animals have tricks or traits to cope with extreme water conditions. If a waterhole dries up, a lungfish can survive because it has lungs, organs for breathing oxygen and air, in addition to gills, organs for breathing oxygen and water. Anywhere that water extremes exist, so do some of the toughest life forms on Earth. Super cold. The water in the polar regions is colder than freezing, 32 degrees Fahrenheit, 0 degrees Celsius. How can that be possible? The water has salt in it, and the salt lowers the temperature at which water freezes, called the freezing point. In the Antarctic region, the ice fish, I'm not going to try and say the Latin, Xenocephalus aceratus, okay, I did try, has a protein that is a natural antifreeze. It keeps ice crystals out of the fish's body, allowing the fish to swim unfrozen under the ice pack. Super dry and freezing. One of the Earth's driest places is the Dry Valley, a frozen desert in Antarctica. There is no rain and very little snowfall. Yet, many organisms, including brown clumps of bacteria, live in spaces between rocks where tiny amounts of water remains trapped. The water is frozen all winter along with the bacteria, but summer heat provides a brief thaw. Super dry and scorching. The Moloch lizard, also called the thorny devil, that guy, lives in the Australian desert. Not enough rain falls to quench its thirst, so it must get its liquid elsewhere. Molochs have spines slanted toward the corners of their mouths, which catch morning dew and feed it to them. Molochs also eat ants, about 1,000 in one sitting. Super acidic. Peat bogs are the wetlands that are almost as acidic, sour, as vinegar. A moss called sphagnum causes this acidity. The spongy, mossy plant absorbs water and minerals and releases hydrogen gas. The hydrogen makes the water acidic. Few animals can survive. Sundew plants have evolved a unique way of getting nutrients in a nutrient-poor bog. Their sticky surfaces trap and digest passing flies. Super speedy. Water zooms down mountains, over waterfalls, and through narrow rivers between lakes. Trout thrive in this swift water because the water bubbles with oxygen. These fish are strong enough to swim against the current. However, in order to avoid being swept downstream, the insects and other small animals cling to rocks. Mussels, below, use sticky threads, while barnacles make a strong glue. Other swift water animals have developed hooks, anchors, or suction cups as sticking devices. Super hard. Minerals are materials that can be dissolved in water. Hard water is water containing minerals, which themselves contain elements such as iron, copper, cadmium, arsenic, and nickel. It is not the hardness of the materials that determines the hardness of the water, but the amount of dissolved materials in the water. Oxygen and hydrogen do not possess the quality of hardness in the liquid state. Hard water is a problem because it can clog water pipes. It also requires more soap for you or your clothes to get clean. Some of the dissolved minerals may coat your skin and cause itchiness. Dissolved in the Rio de Tinto in Spain are iron plus other minerals. Oxygen from bacteria in the water causes the iron to rust, thus tinting the water red. That must be the red water. There it is. Super salty. The shallow Great Salt Lake in Utah is almost 8 times saltier than the oceans. Salt attracts the less salty liquid inside organisms, causing them to dehydrate. Few animals can withstand briny, salty waters. Brine shrimp, left, are an exception. To avoid drying out, they keep their insides as salty as the water, creating a stabilized balance. Super speedy. He's so fast. Water zooms down the mountains, over waterfalls, and through narrow rivers between lakes. Trout thrive in this swift water because the water bubbles with oxygen. These fish are strong enough to swim against the current. However, in order to avoid being swept downstream, insects and other small animals cling to rocks. Mussels, below. Oh, I already read that. Sorry, I'm losing track of what I've done. Watery world record. Life in boiling water. Deep sea water is normally around the freezing point, yet a crack in the ocean floor can produce smokers, or hot water vents. Superhot, mineral-rich fluid from below the Earth's crust flows up through a crack. An organism called Pyrolobus fumigari thrives in vents just above the boiling point. It stops growing when the temperature gets too cold, about 194 degrees Fahrenheit. That's 90 degrees Celsius. I think that makes sense because 100 degrees Celsius water boils and 212 in Fahrenheit. This is the last one. Mix it up. Some lemonade is a mixture of lemon juice, water, and sugar. You know there's sugar in lemonade because the drink tastes sweet, but you can't see the sugar. Why? Because sugar is completely dissolved in the liquid. Lemon juice, water, and sugar form a solution. A solution is a mixture of which the different kinds of matter are spread out evenly. In lemonade, water is called a solvent. Sugar and lemon juice are solutes. A solute is a matter that dissolves in a solvent. The solvent is often a liquid such as water. Say a solution consists of different amounts of two liquids. The solvent is the liquid present in the greater amount. The lemony ticket. Lemonade has properties similar to other solutions. Once it is completely mixed, a solution is the same throughout. In the case of lemonade, the ratio of sugar to water to lemon juice is the same everywhere in the glass or pitcher. The mixture does not separate if it is left standing or poured through a strainer. A solution has a saturation point. At the saturation point, no more of the solute will dissolve in the solvent. If you add more sugar, it won't dissolve. Instead, it will sink to the bottom of the glass. Refreshing and appealing. One way to make lemonade is by combining lemon juice, water, and sugar. Water, sugar, lemon juice, lemonade. Ocean water is a solution of salt and water. There are roughly 2.2 pounds of salt in every cubic foot of ocean water. 2 2/10 pounds. 2/10 of a pound. That is strange then, because pounds are actually done in ounces, and there are 16 ounces to a pound. So to figure out what 2/10 of a pound is, you'd have to make an equivalent fraction to a 16th, and that's very difficult. I don't want to do that right now. Cubic foot of water is all the water that could fill a container, 1 foot high, 1 foot wide, and 1 foot deep. If all the salt in the ocean could be spread over the land, it would form a layer about as tall as a 40-story building. Wow, that's pretty crazy. Sugar and salt form solutions with water easily, but oil, pepper, sand, and wood do not. Why? The water has to do with the forces that hold the molecules of these materials together. A molecule is the very smallest amount of something. For a solution to form, there must be an attraction between the molecules of the solute and the solvent, in this case between water and oil, or sand and pepper, or wood. When the attraction is not strong enough, the solvent does not spread out in the water, and no solution forms. Water can form a solution with air. The result is humidity. Like other solutions, air can become saturated with water. When that happens, we say that the relative humidity is 100%. As the temperature cools down, the air can hold less water. What do you think happens then? It rains, of course. It's not the heat, it's the humidity. Mud puddles and fog are mixtures, but neither is a solution. Mud puddles and fog are suspensions. A suspension is a mixture of bits of matter that are big enough to be seen. A mud puddle is a suspension of soil in the water. Fog is a suspension of water droplets in the air. The matter in most suspensions can be separated with a filter, but not fog. It is a kind of suspension called a colloid. Colloids have very tiny particles of matter. As a result, they cannot be filtered easily. Scientists have found a way to use evaporation and other methods to create fresh water from ocean water. The process is called desalination. Desalination is important in areas of the world where fresh water is scarce. However, the process is extremely expensive. I really think we're done now. Okay, just so we could finish. Water swirls, creates giant waves, froths, and bubbles, falls great heights, and reflects images and colors. Artists, however, do not look at what water is, they look at how water appears. The images at right were done by Japanese and Chinese artists. Using crayons, colored pencils, or markers, draw your image of water in the blank spaces to the right. Well, here's water. Here's water. I like this one a lot. And then there's a blank for you. Water acrostic. Fill in the blanks with the answers to each clue. The letters in the squares will spell the name of the process by which a gas becomes a liquid. Number 1 is a deep crack in a glacier. Number 2, one component of water. 3, Roman god of the sea. 4, gooey liquid of chemical impurities removed from water. 4, author of the rhyme of the ancient mariner. Moss. 6 is moss that absorbs water and releases hydrogen. 7 is the tendency of water molecules to stick together. 8, animals that cling to rocks using sticky glue. 9 is the process by which water becomes a gas. 10, a fish's organs for breathing in water, oxygen from water. 11, ship with underground wings. 12, compact ice formed by layers of snow pressing down. Experimenting with water. To learn more about the properties of water, try these experiments. What happens when warm and cold water mix? Add a drop of red food coloring to a cup of hot water and a drop of blue food coloring to a cup of cold water. In a clear plastic cup, pour half of the hot water. Then add the cold water. What happens? What happens when you pour the cold water into a cup first? Salt lowers the freezing point of water. See for yourself. Fill an ice cube tray with water. To half the bins, add different amounts of salt, from a few grains to a spoonful, and stir. Set the tray in the freezer. Which bins freeze first, last, or not at all? Frozen water is normally clear, but trapped air turns ice white. How can you make an ice cube that's clear? Experiment. Fill different compartments with an ice cube tray with very hot tap water, very cold tap water, distilled water, salt water, and soda. Make a map that shows what you put in each compartment. Set the tray in the freezer overnight. Which ice cubes are the clearest?